So yeah, let's bring Alex aboard. Alex Anderson is teaching about TypeScript at ui.dev, and he's building a spaceship game at Thorium Sim. Let's bring Alex aboard. Alex, tell us about your spaceship experiments.
Well, why don't you pull up my screen really quick and I will show you.
Yes, let's do it.
Yeah, so I'm working on a spaceship video game in browser, built with React and tools like Three.js and that sort of thing. This website, thoriumsim.com, it's actually built using Prisma. So that's my single Prisma shout out for the
Yes,
entire presentation.
love it.
But the idea is it's like a spaceship game where you're flying around in a spaceship, except you have a bunch of friends come with you. So you have somebody who's the captain giving the orders, the navigation who flies the ship, weapons who defends the ship, an engineer who fixes everything, that sort of thing. Everybody has their own position, their own role, trying to accomplish a mission together. So it's open source and we're looking for contributors. So if you're interested in checking it out, take a look at the GitHub, join us on Discord, all that stuff.
That is very cool. I can say I would not want to be in the captain's chair, at least not to start out. We all saw how I tried sharing my screen earlier. So running a spaceship maybe is a little bit down the road. But
Maybe, yeah.
Alex, we really appreciate your time. Without further ado, I'll give you control here of the floor, and you're going to tell us about Remix resource routes. Thanks, Alex.
Sure thing. And I'll just give another shout out to ui.dev. This is what I do for my day job. I'm teaching TypeScript and if you want to learn more about TypeScript or React, or if you know somebody who wants to learn those things, send them our way. Also, sign up for bytes.dev. It is an incredibly relevant and incredibly irreverent newsletter that we drop in your inbox every week talking about JavaScript stuff. So we'd love to slide into your inbox every week if you don't mind. With that, we're talking about resource routes. Chance touched on them a little bit. They're basically a route in Remix that doesn't give you any UI. Instead, it gives you whatever you want. Instead of returning HTML, it returns anything. It's basically like an express route that you can return whatever you want with. So we're doing some weird stuff with them today. Chance demonstrated that you can use it to create a REST API using Git and Post. We're going to be doing other things than that. And these are the things we're going to be looking at. So I've got my code over here, which we'll be looking at how each of these things is implemented. But we'll start off at the top with the webhook API. Suppose you're building a little automation to make it so that when different labels are added to your GitHub issues, they are automatically rearranged in the GitHub project's beta. So here I have JSON payload for an issue that's had something happen to it. It looks like it was closed. And we're going to use the GitHub or the Remix resource route to make it actually make those adjustments. So we'll go into app and then routes, and then I have it in the webhooks github.ts file. And we've got a whole bunch of things going on here. I've got GraphQL queries for each of the GitHub project's beta queries we need to make. So this one gets data from the project. This one adds a issue to a project. We can change the status. We can delete items, that sort of thing. And down here is where the magic actually happens. I'm using a remix action because the way that the GitHub API works or webhooks works is it sends a HTTP post message to an endpoint that you specify. So if I wanted to do that, let's see here, if I'm adding a webhook to this repository, I can say HTTP : // This isn't going to work properly because it can't send messages to my localhost, but I would say localhost 3000 / and then the route that I want to use is webhooks / GitHub. So I'd say webhooks / GitHub. And I can choose the content type, either XWWW form URL encoded or application JSON. That's the one I'm going to use. And like it says up here, it's going to send a post request to this URL using the content type that I specify. So here I use action because I want to, because I'm receiving a post. If I was receiving a get, I would use a loader, and that's just the way that Remix routes work. I parse the body into JSON. I get some data using those GraphQL queries that I had up above. I define some functions for executing those queries. And then down here is where we actually deal with the body itself. So I have two different things. Sorry, it looks like three different things that I can do based on whether it's an issue we're dealing with, a pull request with a review, or just a regular pull request. And I'm just switching based on the action of the payload. So over here, see that the payload action is closed. So I can scroll down and see here is the closed action. We're going to make sure that it's been added to the project. We're going to get some information out of the issue that we're adding. And then we're going to change the status. If the item, if the issue was pre-approved, if it was supposed to be included in the project, then we're just going to change its status to done. And if it was not in the project, if it was not approved, then we're just going to remove it from the project altogether. And that's it. And I have different actions for all of the different actions that I want to have happen. So if an issue is opened, or if an issue is reopened, or if it's labeled, or all of that stuff. And then at the very end, I have this return JSON. This JSON comes from, let me see, it comes directly from Remix. So I'm returning just a regular JSON payload. I say that success true is the payload itself, and then I set the status and the headers to make sure that GitHub is able to parse it properly. And then in the event of an error, I say success false, since that's what GitHub's webhook API is expecting if there is a problem, and then GitHub can tell me that there was a problem with it. And so I can take this JSON payload, we can come over here and post it. So I'll say webhooks/GitHub as the URL. And for the body, I'm going to do a raw JSON request, paste in that body there. I'll click send. It's going to do its thing, and it's going to say success false because something happened. It blew up for some reason. It looks like we can see it's not able to actually read some properties because I haven't set up environment variables in order for it to be able to access the GitHub repository. But you can see, even though it failed with glory, and actually told us that, like, we can see that this is actually behaving the way it's supposed to. It returned a JSON payload after attempting to do something. So that is how you can use Remix resource routes for webhook APIs. Specifically the GitHub API, but this works with any webhook API. You just have to add the webhook pointing to that specific route that you want, and then it'll send the messages there. You can add a secret if you want to make sure that it actually is coming from GitHub, whatever you want, and it'll just work. Let's see. The second thing we want to do is dynamically generated CSS. And this is one where you can have a little bit of fun with it. The idea is you can have CSS that lives inside of your public folder, and that's just going to be available. Like most frameworks, like Next or Gatsby, the public folder is just provided to you verbatim. So we've got the favicon here, which is just going to render on any page. You can access it by going to /favicon.ico, and it'll just work. And I can put CSS files in there, and they'll just work too. But what if I wanted to make it so that the CSS was dynamically generated based on something? Data in the database, in my lovely Prisma database, a cookie which the user sends, URL parameters, something. I want to adjust the CSS magically based on some data. Today, I'm going to keep it simple. We're just going to have a random style. So here is the actual HTML that I'm returning. It's an H1 with the class name of random color, and I'm accessing it. I'm pulling in the CSS using the links API, which is part of Remix. The way that you add CSS to a page is by exporting a function called links that returns an array of the link tags. So the tags that are like link rel equals whatever. And Remix is going to render these in the head of the page, and it's going to dynamically swap them out whenever I change pages. When I say pages, I should be saying routes. That's technically more accurate, but you know what I mean. Let's see. So I have rel style sheet, and href is /randomstyle.css, and that is coming from this file right here that has a very weird name, random style square bracket .css close square bracket .ts. This is actually another Remix thing, which lets me change or specify the extension of the route. Okay, so you can use Remix resource routes to return anything like JavaScript, like a PDF, and you might want to make it so that when you access that particular route and it returns that particular thing, it has the .pdf or .js or whatever extension you want. This is how Remix lets you do that. So this is still a TypeScript file because it does end in .ts, but when I go to access it on the browser, in fact, let's do that right now. I'll go to /randomstyle, yeah, .css, and it gives me a CSS file. And we can see every time I click the refresh button, it gives me a random hue in HSL. So if I go to the actual page, every time I refresh this page, it's going to give me a random color because it's loading that dynamically generated CSS. It's dynamically generating the CSS file every single time. The way that it's doing that is just by interpolating the CSS string, and then I return it using a response object. This is actually part of the web API. This is how Remix does responses. The JSON helper that I was using before is just a wrapper around response that automatically adds in the application JSON content type. But since I want to use a text CSS content type, I'm doing a raw response here. So this is the text of the response. This is the headers with the content type of text CSS. And that's how my browser knows that it's actually loading the CSS file. I could put whatever I want in here. I could load data from the database and use that to determine the random color. Or I could make it so that the user's theme is stored in a cookie. I pull the theme out of the cookie, and then I dynamically generate the CSS for that user based on the theme that they want from the values in their cookie. Or it could be that they want to specify specific colors for specific things. I want the text to be this, and I want the body to be this, and I want whatever. You can do that, whatever you want, and it just packages it into a nice CSS file dynamically generated for each user. You could cache it in a Redis database. You could do whatever. It's your application. You are the programmer. The power is in your hands. And Remix just happens to make it really easy. So that's our random style. Let's see. If anybody has any questions, feel free to pop them in the chat. I will pull them out of the chat when I get to breaking points. But we are going to move on and take a look at cached CSS and JS. Okay. Now, I actually want to go to the Remix documentation for just a second and see what they have to say about CSS and JS. I know that for a time they were like, you shouldn't use CSS and JS because reasons. But now in the documentation, it specifically says you can absolutely use CSS and JS libraries like styled components. Some of them are going to require a double render because you have to first render the page with all of the routes, and then you have to extract the styles from that page and then render again with the styles applied. But they say it's unlikely this will affect your performance. React is pretty fast, and this is true. I've never had a problem with the double render because unless your page is absolutely bonkers with thousands of components, it's probably going to render really quick. That being said, it might be possible. There might be situations where you want to make it so that your CSS and JS styles are cached so that you don't have to do the double render every single time. You only have to do it once based on the contents of the page. That's what I'm doing here. I'm rendering this with CSS and JS. Ooh, and we can inspect it and see that it has some Tailwind styles, but I'm actually not loading Tailwind in this app. I'm using a CSS and JS library called Twind. Let's see. I want CSS and JS right here. Okay. And I'm just loading the TW utility from Twind. and I am using it with a template literal tag right here to choose which Tailwind styles I want. And then it is automatically going to generate the styles with the classes for whatever Tailwind styles I put in here. Instead of having to set up Tailwind with the purge options and stuff. It's just going to do it itself. Although the Tailwind JIT mode is really awesome. So definitely check that out in Tailwind 3. So that's how I'm getting the styles. How am I caching it though? Well, you can see here, I've got this styles.ts file, which is another resource route. This is what's actually generating the styles. You can see that I'm pulling out the URL. I'm getting a hash from the search params. And if there's not a hash, then it's going to throw an error, but that hasn't happened yet, so no worries. And if it did throw this error, I could catch it with a lovely error boundary. I'm not going to talk about error boundaries either, but check the docs for those because they're cool. And then we're going to use this get styles by hash utility that's coming from the style context utility. And if there's not a styles in the hash, if there's not a cached style, then it's just going to return a 404. Otherwise, it's going to return my style data that's been cached using the text CSS content type with a very long cache control. And that is that. Well, so the idea here is we're going to be able to go to the CSS and JS /styles with a hash URL search param, and it's going to give us styles for that particular hash. So where do these styles come from, and how do they get hashed in the first place? We'll go into the get styles by hash utility function, and we can see we're actually putting these into global. So that's where our styles are cached, is just in memory. But we could cache them in Redis or some other caching mechanism by the hash, using the hash as a key. And that's how we're getting the styles. How do we generate the styles in the first place? We're using this render with styles function. Okay. We have an edit styles function, which is initializing the styles to begin with, creating our cache, setting up Twinned, and creating a virtual sheet, which is the way that Twinned does server-side rendering. And then every single time we render our app in entry.server.tx right here, instead of using the React render function, we're using render with styles, which wraps the React render function down here. This is where we're calling render to string. And this is where we do the double render. We first render to string to get all of the styles for the first time. We use the get style tag properties function, which comes from Twinned, to get all of the style tags, the styles themselves, out of that sheet, which Twinned has already set up. We're going to remove white space. And then what we do at that point is we hash the styles. And we store the styles by hash, feed the hash to the app, and render it again using this style context provider. And that is what actually renders the styles, puts them into a style sheet that we're accessing with the resource route, and then actually rendering the app so that they're cached. Let's see. And then we have this use styles hook, which is rendering a link component itself using the get path for hash function to get the appropriate link to the resource route, which is rendering the styles. But we use that in our root component right here to actually render the styles, and we render those right here in our head tag. That sounds like a huge rigmarole in order to get CSS and JS caching and working properly. That's why I mentioned at the very beginning that Remix says you can absolutely use CSS and JS libraries. React is fast. It's not going to be a problem. But you can use resource routes to cache your CSS and JS to make it so that you don't have to deal with that double render every single time the page is loaded. It can be just a little bit faster for most of your users otherwise. Okay, let's do something a little bit weirder. I'm just going to close some of these, come back here, and come back here. And we're going to do some dynamically generated JavaScript next. And to demonstrate this more fully, we're going to render a svelte component. Okay, so here I've got this svelte folder inside of my app folder that has this app.svelte file. And it just has a div with some scoped styles. I don't have any nested components. I don't have any state. I don't have any of that stuff. We're just keeping it simple. But this is going to render this to the page after generating the JavaScript for Svelte. Okay, so let's take a quick look at how that works. We've got inside of our routes folder, we've got another Svelte file. And in here, I'm using loader because we want this to respond to GET requests. I'm going to use fs read file sync to pull in our Svelte app, and I'm going to compile it using Svelte's SSR configuration option. I'm going to evaluate it using eval, which is dangerous. That's how you know that we're having some fun here. And then I'm going to use component.render in order to render it to actual HTML. From there, I generate a little bit of HTML boilerplate. I put the CSS in a style tag at the top. I put the output HTML inside of the body. And then we're going to render it using the text HTML content type. So this isn't actually dynamically generating a JavaScript file. It's creating a JavaScript file, executing it, and turning it into HTML all in this loader. If I wanted to add some lovely svelty dynamism with state and other components and stuff, I absolutely could do that. Generate the JavaScript here in a loader and load it, and that would be positively bonkers. But you can do that. It's allowed. So let's see. Ta-da! This is rendered with Svelte. Hey, Austin. Hopefully you don't do this. This is like possible. It might not be a bad idea, but it might be a terrible idea. It depends on what you're doing. I can absolutely see some situations though where this might be what you want to do. You actually legitimately want to do something like this. For example, if you are loading in some third-party libraries and you want to embed the API token keys for your third-party libraries inside of the JavaScript file, so you don't have to just keep those in global environment variables. You could do that with this kind of thing, where you're returning, instead of text HTML, application JavaScript, and have a dynamically generated JavaScript file. Suppose you embed Remix into an Electron app, and you want to make it so that your Electron app loads plugins from the file system. You could do that using a resource route with loaders that is able to pull in all of the data that you need, render it properly, and return it to the Electron app using a Remix API resource route, and do it that way. You could load ESBuild into a loader and use ESBuild to bundle these plugins, and you can do it. And like, the concept itself is absolutely bananas, but the actually doing it is very, very straightforward. Remix makes it really easy. The resource routes allow you to return whatever you want, and it just works. Let's do, for my final trick, we are going to dynamically render some video. We're going to do this using a library called Remotion, which lets you pass in a React component that uses some special hooks to hook into a frame rate and a current frame. And you can use that to animate all kinds of stuff. So I'm going to come in here and do this video on demand. Ooh. Type in my GitHub username and click create video. And you can see down here it's loading. I actually want to pull open the network tab as we do this, and we'll watch what happens. Let me see. I want to do that. So it generates this video. I'm going to replay it. It pulls up. It says, "Hi, me. You have 119 public repos." Okay, let's do another one. I'll do ui.dev, and we'll watch the network tab, and we can see it's pulling it here. Let me pull that up, and we'll look at the timing for this. And let me actually make that a little bit bigger. So we can see what it does is it waits for 3 seconds with this time to first byte, and then it downloads it. And during those 3.79 seconds, it's actually generating the video on the server and then providing that, streaming it, passing it to the browser on demand. Just for kicks, we'll do one more Prisma and loading. And there it is. Hi, Prisma. You have 70 public repos. Woo, you're so cool. So let's take a look at how that works. That's happening in the, well, first we have the video route, which is a normal route. We're returning we're exporting a default function that's a React component. Right down here, we're using the form action API in Remix, which lets you call an action, which is a way of calling a post request, basically. So we have this form method post, and we're passing in the GitHub username. We have a button, which is a submit. It's going to submit and do stuff. And it's being submitted to, oh, that's weird. Where is it being submitted to? Up here. Hey, it's being submitted to the same file where we have our action up here, which is responding to that post. We're pulling out the GitHub username. We have a little cache just to make it so we don't have to hit the GitHub API so often, so we don't hit in API rate limits. Make sure that it's a valid username, and then we return the username. Awesome. And then down here is where we're actually, so we return the username from this action. So when we hit the submit button, it fetches from the GitHub API, makes sure that it's a valid username, and then returns that username. And that's going to be provided in this action data with the use action data hook from Remix. So down here in the action data, we check to make sure that there is a username in the action data. And then we're passing in this source to the video element with /API/video/ and then the username. That is going to go to this resource route right here, API.video. The dots turn into slashes in the URL. That makes it so we don't have to nest folders forever. So we have API/video/ and then name is the username. It's a URL parameter. This right here is going to get a little bit hairy, but bear with me. We're going to do another check to make sure that the user is correct. We're going to get that data from GitHub, but that data has already been cached if it's coming from here because the cache is being shared. Yeah, we've got this GitHub cache. So we're automatically putting that in to the cache. No, we're not. That's silly. It should be put into the cache when we make the request here because we're making the request twice. Whatever. I'm a silly programmer. And then we're pulling out the video, the user data from GitHub with the avatar, the login, and the public repos. From there, we're going to call this bundle function. The bundle function is coming from Remotion. And we also have a couple of utilities from the Remotion renderer. What bundle does is it takes a Remotion React component file, in this case, app/video.tsx, which we'll look at in just a second. And it's going to bundle it using Webpack. So we've already got Webpack being loaded in here. That's what Remotion uses. We're going to get the compositions that were created as part of this bundling process. We're going to create a temporary directory to store some Remotion files that it uses. The way that Remotion works is it uses a headless browser like Puppeteer in order to take screenshots at every single one of the frames. So it renders the frame, takes a screenshot, then goes to the next frame, renders the frame, takes a screenshot, goes on. And then it's going to render all of those frames doing that. It's going to stitch all of the frames together into a video. And then it's going to output it to a file. So from there, I have the final output that's coming from my stitch frames to video function. I turn that into a FS read stream. And then from there, I can just return the read stream as a response with the appropriate content type, content length, and cache control properties. And it's going to return it as a actual video. It's going to stream that video that was just generated that's currently in the file system. It's going to stream it from the file system to the person who's requesting it. Really quick, we're going to take a look at the video just for fun. That's in the video.tsx file here. The way that Remotion works is you register the root, and then you load in the component that you want to render. So that's coming from component/remotion/video. I've got this composition file where I'm passing in the GitHub demo component. Let's see. That's not what I want. This composition is coming from Remotion. I'm rendering the GitHub demo. And then I say how long I want it to be in frames, the frames per second, and the size. So let's go to the GitHub demo component. Right here is the data that I passed into this component when I rendered it, when I created it, which includes the username and the profile picture and all of that stuff. Remotion has a bunch of tools like measure spring and interpolate and stuff that make it a little easy to do some animation. So that's what I'm doing to generate the movements and the opacity and stuff. But I'm just rendering this stuff. I've got hi data.login. I've got the public repos here. I'm rendering the image here, and Remotion just takes care of it for me using the frames right here to I get the current frame, put it into the spring to get the progress, and then it renders everything properly. So that is that. That's how we're able to render these lovely videos. I do want to give a shout out. This video demonstration was originally demonstrated by this person here, L. Gastler, who first demonstrated how to do this properly. One important thing to note is this is only going to work on an actual hardware server. It's not going to work serverless because of the way that it operates and the dependencies that it needs and that sort of thing. So just running it on an actual node server works a little bit better. So that is all I have to talk about now. Hector in the chat has a question. Says, hello, Alex, nice talk. Regarding remix architecture, is there any way to split backend responses and front-end ones? And the answer is yes, I guess. What I'm talking about right now is resource routes. This is a little bit lower level than the normal routes that Remix expects you to return. Remix operates on a server-side rendered type architecture where every single route is going to be server-side rendered. And it also is going to, well, if you load JavaScript on the page for that particular route, it's also going to load up a client-side route so that when you navigate around, it has some nice client-side transition stuff that we're all used to with React single-page apps. And that's all taken care of for you if you just use Remix the way that it is. So there is always going to be a back-end server-side generated component to it and a front-end client component to it. And those two things work together. That's why Remix is so great. Everything that I've demonstrated today with Remix resource routes happens on the back end. There isn't any JavaScript running in the front end in the resource routes themselves because the resource routes respond to an HTTP request. And that's one way that you can separate your backend from your front end. If you just wanted to render HTML, you could use a resource route like I did for the Svelte demo, where I just generated the HTML and then returned it. Another option is to conditionally load your script tag. So here I have a script tag in my root component, but I could make it so that the script tag only renders on specific pages, on specific routes, and the routes that need to have JavaScript. And then on all of the other pages, I just don't render it, and it just gives me HTML, completely server rendered, no client-side stuff. On the flip side, if I wanted to make it so that some content only renders on the client, I could create a component that is able to detect whether it is in the server environment or a client environment and conditionally render in that case. So that component would look like client only. And I would say if window or type of, I've got GitHub Copilot, which is really awesome, by the way. You should definitely sign up if you haven't already and get on the wait list because it takes a while to get it. So if window is undefined, that means we're in a server environment. Otherwise, we can actually return whatever it is we want to return. So we'll grab some children here from props, and children is a type React node. Yep, that's the type of that. And then I can just return the children in that case. Then when I actually go to render, let's see, suppose I only want to render my head tag. I don't even want to render my children in a server-side rendered setup. I could say client only like this. And oh, this apparently it doesn't like this for some reason. So I'm just going to wrap this in a React fragment, and now it's happy. Okay, so now this client only component is going to make it so that if I server-side render this, it's not going to render anything inside of this component, which means my children aren't going to render. It's just my head tag that's going to get rendered and the scripts and all that stuff. And then once it hydrates on the page, once my JavaScript actually loads up, it's going to run a React render at that point, and then it's going to render all of the content. This obviously is a bad idea. Well, I shouldn't say it's obviously a bad idea. I think it's a bad idea. If you might as well take advantage of the server rendering that Remix is giving you, but it's an option. And there are some situations where you do want to not render clients or components in the server. You just want to render them in the server. Same thing with not executing client-side JavaScript, just executing server-side rendering and just getting back HTML. Hopefully, Hector, that answers your question. That's all I have to say. I think I am done. So thank you very much, everyone, for having me.
Alex, thank you so much. That was a lot of fun. I'm a big fan of seeing what kind of mad science we can get up to with these new tools and kind of stretching them. And resource routes seems like a great way to do that. So thanks so much for your time and your preparation.
Super. Thank you, Austin. It's been a pleasure.
Thanks. Everyone, go follow Alex and Chance on Twitter. Chance is at Chance the Dev, Alex at ralex1993. With that, we have finished up the talk portion, but don't worry, I didn't forget about our raffle. Again, 5 tickets going out for Node Congress, which is happening just in a few days. And those winners are these 5 lucky folks here. So if you see your name on the screen, you should be getting an email with your ticket. Have a good time at the conference, learn a bunch, and we're happy to do it. So with that, that's the end of our Prisma Meetup Remix Edition. Thanks so much to Chance and Alex for their time. We really appreciated it. As usual, we'll chop up the talks and get them posted on YouTube in due time. But in the meantime, everyone have a great rest of their day, and we'll see you at the next Prisma event. Thanks very much.